There's been a lot of talk lately at TVA and in the news about the Bellefonte project, and you'll be hearing more over the next several weeks. To give you a look at why Bellefonte is an attractive option to help TVA achieve its vision with more carbon-free nuclear generation, this short video will take you inside the plant. This virtual tour was recorded recently to show firsthand the existing assets that could be put to use generating the electricity that fuels our region's economy. From the air, the Bellefonte site looks very much like any of our operating plants, except for the rather empty parking lots. Some personnel are working at the plant doing walkdowns and engineering work to prepare for construction work should the completion of Unit 1 be approved. Unit 1 is estimated to be 50 to 55% complete due in part to removal of components such as feed water heaters that used to be in this area, and equipment such as the motors for these water pumps, and materials such as the tubing in the main condensers. These were removed from Bellefonte and in some cases put to work at other plants during an investment recovery effort a few years ago. However, the true value of Bellefonte is in the assets that remain. If we were to start from scratch, all of the infrastructure that already exists would have to be built from the ground up, including the buildings, the cooling towers, and the switchyard. The big brown-sided building is the turbine building, where the turbines that drive the generator and associated systems and components are located. The concrete cylindrical structures are the reactor buildings. Each of them houses an airtight containment where the nuclear reactor and the systems that circulate water through its core and produce steam to drive the turbine generator are located. Although distinctive and massive, cooling towers are really just big chimneys. Water from the cooling tower is circulated through the main condensers to cool and condense steam from the turbines. When the warm water returns from the condenser, it is sprayed inside the lower portion of the cooling tower, where it falls to the basin below. As it falls, air cools the water and the warm, moist air rises through the cooling tower due to the chimney effect of the 500-foot tall tower. The switchyard at Bellefonte was once an active part of the TVA power system. To support a completed unit there, the 500 kV transformers would be replaced with upgraded units, and some of the other switchyard equipment would be refurbished to a like-new condition. Here on the turbine floor, we see the 4 main steam lines entering the building. They combine into 2. From here, they pass through the floor and return to drive the high-pressure turbine. After the steam passes through the high-pressure turbine, the steam is reheated and sent to a pair of low-pressure turbines. All of these turbines are connected on a single shaft to the electrical generator. As part of the construction, the internal components of the turbines would be upgraded with newer, more efficient ones. The new equipment would pay for itself by enabling the generator to produce more electricity than the original equipment. These turbine generator components are just a couple of the existing assets inside the plant that offer more value to TVA. While some of the existing components shown in this video have paint that is discolored or peeling, the work to refurbish the equipment would include repainting to protect and preserve the surfaces. The nuclear reactor components are also high-value assets. The Bellefonte reactor vessels are made from huge steel forgings. Having these vessels and the components that go in them puts TVA in a unique position to be able to complete the plant without waiting in line to have new vessels manufactured. The Bellefonte plant also includes innovations not found in existing nuclear plants. These innovations are the result of design improvements that were made based on experience with other projects. An example of these innovations is the permanent walkway next to overhead cable trays. Technicians would use these walkways to do maintenance or modifications on cables routed in the overhead areas of the plant. Without these walkways, temporary scaffolding would have to be built every time this type of work needed to be performed. A significant feature of the Bellefonte design is its used fuel storage facilities. Each unit has its own used fuel storage pool, and the pools are well protected inside a room with concrete walls and ceilings. These rooms are located inside the concrete auxiliary building between the reactor buildings. There are 2 fuel transfer tubes for moving nuclear fuel back and forth between the fuel storage pool and the reactor. This redundancy helps assure the refueling outages are completed efficiently. Another design feature is easy to miss for those not familiar with nuclear power plants. It's the spaciousness of the plant itself. For example, the increased size of the turbine building over other plants ensures there's plenty of room for disassembly of equipment for routine maintenance. The turbine area also has 2 overhead cranes on each unit, so that work can be done simultaneously on different equipment. A key safety feature of Bellefonte is its dual containment design. The primary containment surrounding the reactor is itself surrounded by secondary containment. The primary containment consists of a 3.5-foot reinforced concrete-lined wall with a 1/4-inch welded plate steel liner. The containment is 267 feet tall inside and 135 feet in diameter. The secondary containment, or shield building, is built around the primary containment. Its reinforced concrete walls are 18 inches thick. It is 289 feet tall and 160 feet in diameter. Having a containment design that nests one strong building inside another strong building helps protect the safety of the plant and the public. If Bellefonte completion is approved, this strong containment design would be complemented by other improvements that have been developed and evaluated in response to the events in Japan. Those improvements would further increase the safety of the plant and are estimated to cost less than $100 million. In all its plants, TVA works to use the latest technologies and safety features, and Bellefonte is no exception. Many technology upgrades would be used here. For example, at Bellefonte, digital instrumentation and controls and a complete redesign of the control room shown here would be performed. The current control room would be replaced with redundant and secure computer systems and dozens of large screen monitors. When completed, the control room would be one of, if not the most modern, in the world. To optimize the function and efficiency of the control room, a full-sized mock-up will allow planners to configure changes before the design is finalized and construction begins. I hope this quick look inside Bellefonte has helped your understanding of the plant's status and the potential it holds for TVA's future as a leading provider of low-cost and cleaner energy by 2020.